Our next reaction is the halogenation of benzene. Now here we look at how benzene reacts with halogen, how it reacts with halogens. So this is the reaction of benzene with halogens. Halogens specifically we imply bromine gas and chlorine gas. Still, this reaction occurs in presence of halogen carriers or in presence of Lewis acid catalysts to form halobenzene or aryl halides. Now, this reaction is similar. This is Roman form. This reaction is similar to Roman 2, which was Friedel-Crafts alkylation. It is also similar to Roman 3, which was Friedel-Crafts acylation. They are similar. They are similar. We are not going to change much. That's why here there is this important note. Since the reaction occurs in presence of Lewis acid catalysts or halogen carriers, these Lewis acid catalysts are the same. They are the same, not that. They are the same. They are the same as those discussed under Friedel-Crafts reactions. That is Roman 2 and Roman 3. And they serve the same purpose as explained earlier on. I do not need to explain that again. If you are watching this for the first time, refer to the previous videos where we looked at Roman 2. I did a lot of examples on Roman 2, Friedel-Crafts alkylation, and also on Roman 3, Friedel-Crafts acylation, where I explained the roles of the Lewis acid catalysts. They are catalysts or they are halogen carriers that are electron pair acceptors, and for that purpose they induce polarity of the bonds, resulting in formation of an electrophile. So now here I can look at examples. Take note of this note. It is very important because they can ask you to identify the roles of the Lewis acid catalysts. That question is highly examinable. I have explained the roles of those acids in Roman 2 and Roman 3. Now I look at examples. Now the first example, we have benzene reacting with bromine in presence of aluminium bromide. Having highlighted enough examples in part 2 and part 3, the mechanism is the same. The mechanisms are the same. We can have two approaches. So here I'm going to bring my benzene ring. Reacting with the bromine. So I write my bromine in this form. Then my Lewis acid catalyst or the halogen carrier. Now the halogen carrier has a central metal atom which has vacant orbitals, so it is electron deficient as highlighted earlier on. So we can have this donating there. So this has a partial negative charge, partial positive charge, implying that this bond is polar. So this is electron deficient. Benzene now can donate to it. As a result, we shall form the following. So we have our benzene ring. That is our benzene ring. There is a bond there and a bond there. So bromine goes to the nearest carbon with more hydrogens, but from the previous discussions, you all agree with me that it can go up there or down there. So if it goes up, there is a plus on that carbon atom. Then this bromine and the Lewis acid catalyst will form LBr4 with a minus. Then I can expose the hydrogen here. Expose it very well so that donates electrons to that electron deficient carbon, and as a result, I hope this space will be enough. As a result, I lose a proton hydrogen ion as I form my bromobenzene. As I form my bromobenzene. Like that. Then the hydrogen ion plus Al Br4 minus, so this donates electrons to electron deficient hydrogen, so that will form hydrogen bromide plus aluminium bromide as aluminium bromide. So here I have bromobenzene. Let me hope you are not going to ask me the name of this compound. I have already mentioned it. It is bromobenzene. Bromobenzene. Like that. Bromobenzene plus hydrogen bromide. Hydrogen bromide. That is the first example. In the second example, I have methylbenzene reacting with chlorine. So I'll bring my methylbenzene here. Methylbenzene. Example 2. Reacting with chlorine. So I write my chlorine like that in presence of Lewis acid catalyst aluminium chloride, like that. So there are vacant orbitals within the central metal atom in this Lewis acid catalyst. Therefore, chlorine, one of the atoms of chlorine can donate electrons to the central metal atom. So this has a partial negative charge, partial positive charge, electron deficient. Then benzene donates to it. The results obtain the following. So we have our benzene ring. There is a bond there and a bond there. Then CH3 is here up. Now from the previous discussions, Markovnikov says that this incoming group goes to the nearest carbon with more hydrogens. Now we have this carbon and that one. From the previous discussions, we have seen that this carbon has more hydrogens. Therefore, chlorine will come here, so that there is a plus there. Then this chlorine and that one, and the Lewis acid catalyst will form AlCl4 minus, like that. Then we have silent hydrogen here. Have a silent hydrogen there. So it donates electrons to that electron deficient carbon. So we lose a proton minus hydrogen ion. And as hydrogen ion, as we form substituted methylbenzene. This is what we form. CH3 up, Cl down, like that. Then the hydrogen ion plus Al4 minus, this donates to the proton, so that will form hydrogen chloride plus aluminium chloride. So the products, do not always forget to complete the reaction. We have this and the hydrogen chloride. That is example 2. Now there are those 2 interesting questions which I am leaving behind. Endeavor to go through them. You outline the mechanisms for the reactions. Yeah, hopefully next time we shall start with the reaction with the acid anhydrides. If you have Any questions, feel free to contact me on the contacts that you all have. Yes. But if you don't have my contacts, below are the contacts. There is this one, also on WhatsApp. There is also this one, also on WhatsApp. I think there are those ones, those two. Now, if you are from abroad, you never know. This information is on YouTube, and the YouTube is accessible. Even those in US can access. Now, if you are a learner from abroad, here in Uganda, our zero represents +256. This is zero before. This is zero before. So this is +256. Also zero is +256. I remain Mwalimu Arnold Sekago for God and my country.